Okay, so now we're going to add on to what we've been doing with stoichiometry, something called percent yield. And this is actually kind of a big deal if you're actually working in industry and chemistry, because percent yield indicates how much you actually get compared to how much you could have possibly got. So stoichiometry tells you how much you could have possibly got. So you start with a bag of chocolate chips, you would have gotten 4 dozen chocolate chip cookies. Percent yield, on the other hand, is a little bit different. Theoretical is what happens if everything goes perfectly. It's the maximum amount you can get. So you're making chocolate chip cookies, you got a bag of cookies or chips, and you can make 4 dozen cookies. Everything goes perfectly, they're all perfectly sized, you get 4 dozen cookies. Actual yield is what happens when it really works out. Maybe you drop the bowl and some of it spills, or maybe some of your cookies are bigger than you expect. So the actual yield is the amount that you actually get when the reaction's carried out. Theoretical yield is the maximum amount you could possibly get if everything goes perfectly, and it's the amount that you get theoretically, according to stoichiometry, what you could possibly get. Actual yield is what you really got. So to compare them, percent yield is a ratio of the actual, what you really got, to the theoretical, which is the stoichiometry part, expressed as a percent. So you take the actual, and this is going to be given to you, generally speaking. This one comes from stoichiometry, multiplied by 100, and it gives you a percent yield. It's like you're scoring a test. You could have gotten a 75 points on the test. You got a 67 points. You actually got 67. You could have gotten a 75. It tells you what your percent is. Same exact idea. Okay, so an experiment is conducted in which 75.2 grams of aluminum reacts with excess HCl. So when you see excess, I just want you to cross that off. You can ignore that for now. According to this reaction, they say 185 grams is actually made, and they want the percent yield. Percent yield is actual over theoretical times 100. Well, I've got the actual right here, so the top number is going to be 185. What I need to come up with is the bottom number. And the bottom number comes from stoichiometry. So I'm going to start with that 75.2 grams of aluminum. Change from grams of aluminum into moles of aluminum. Put a 1 where it says mole. Look it up on the periodic table. This is 27. Grams is canceled out. Then I'm going to do my mole ratio. Aluminum on the bottom into AlCl3 on top. Ratios are 2 to 2. Al cancels out. And then I'm going to change from moles of AlCl3 into grams. And again, put a 1 by the word mole. And you get out my calculator for this one. And the molar mass is 133.5. So this cancels out. And all I'm going to do is go through and solve it. So 75.2 divided by 27 times 133.5 means 372 theoretically is what you could have gotten. And if everything went perfect, nothing spilled, everything was 100%, to get the percent yield, I'm going to take that 185 grams, and I'm going to divide by the amount that I could have gotten, and if everything went perfectly, that theoretical, and multiply by 100. Looks to me like it's about 50%. Yep, 49.7%. So a lot of things went wrong on this one. Not that it's bad, it's just that's the reality of what happened. All right, so let me change it a little bit. It says if the percent yield is 65.8, they want to know what mass could actually be produced. So again, percent yield is actual over theoretical times 100 equals the percent. Well, I know the percent is 65.8. I'm looking for the actual amount. That means I must have the theoretical amount somewhere. And if you look back at this problem, AlCl3, I said theoretically I could have gotten 372 grams from the stoichiometry if everything went perfect. So if I put 372 in here as my theoretical and I do the algebra, I end up with 245 grams. And it makes sense that it should be a little higher than this one because my percent is higher than the last one, which was 49.7. So you just kind of have to work with it a little bit. All right, so go ahead and let's see what you get for this one. Again, when it says excess Na, I just want you to cross it right off. Okay, so start with 6.75 grams of oxygen. Okay, and we're trying to figure out the percent yield, so I need the actual over the theoretical times 100. I'm given the actual, so I know the top number. That's 5.43. What I need is this bottom number that comes from stoichiometry. So grams of oxygen on the bottom, moles of oxygen on top. Put a 1 by the word mole. Oxygen weighs 32. Grams is gone. Now I'm going to do my mole ratio. Oxygen to what I'm looking for, which in this case is sodium peroxide. So Na2O2, 1 to 1. Oxygen is gone. And I want the grams. So 1 mole of Na2O2, and the grams is 23 times 2 plus 32, 78. So, doing the math, multiply the numbers on top, divide by the numbers on the bottom, and I get 16.5 grams theoretical. Meaning, if everything went perfect and 100% of this got transferred, that's my theoretical. So my percent yield is going to be the actual, 5.43, over that theoretical, times 100, and about 33% yield. Okay, so not very good, but that's okay. So it's a pretty simple thing. Just remember its percent is actual over theoretical times 100, and this theoretical comes about from doing stoichiometry every time. Actual I'll give you, or percent I'll give you.